Hello. Today we're going to start with our lesson 2.08, the surface area and volume of cylinders. And as you've been doing, please continue to give me your course and section number. Don't just tell me you're in geometry. I need to know if you're in 202B, 203A, 204A, which if you're watching this video, you're in 202B, and then you give me your section number. Our objectives in this lesson is to define and identify the parts of a cylinder, develop and use the formula for the surface area of a cylinder. Here's some terms that we're going to be using: the word cylinder, axis, lateral surface, right cylinder, oblique cylinder. And these are some that you're already familiar with. We're just using them with cylinders. Here's a picture of a cylinder and what you're going to be working with. This is a right cylinder. See how the axis is perpendicular to the base right here inside the cylinder. And here's an oblique cylinder. Notice how the axis is slanted, and they've had to draw this extra red line for the altitude, so you will be able to determine what the height of the cylinder is. This right here is the net of the cylinder. We're just going to be identifying the parts of the net. Here's what it looks like when it's all folded up. Right here is your radius. I've pointed to it here in the net and pointed to it here in the actual cylinder. This is going to be your height, which is usually this. You can call this your height. Your altitude right here is your height as well. You just got to be careful with obliques. And then these are your bases. Your circles are your bases in both the net and when it's all folded up. And then here is the area. I put this little R for a rectangle, is length times width. Most of the time though in your cylinder, the height will represent your width, but you're not going to know your length. And your length is actually the circumference of this circle. That will represent the length of your cylinder. And I wrote that right here. Length is the circumference of the base. So here is the formula for finding the circumference. It's 2 multiplied by the radius multiplied by pi. So I'm going to plug 2r pi in for length. So here is how I find the area of the lateral face, 2r pi h. And like I said, you're doing the same thing as length times width. We just kind of have to use a different formula for the length. Okay, this is all the same thing. I've just added some stuff to it. It says the formula for the area of a circle is pi r squared. So the surface area formula for the cylinder is the area of the lateral face and the area of the two bases. So you plug that in and you get this formula. Remember, here's your area of the rectangular lateral face, and here is the area of a circle, and you're multiplying it by 2 because you have two bases. So let's do some examples. It says for the cylinder below, find the exact total area. Now I put this here. Exact means to leave your answer in terms of pi, and I'm going to show you what that means in just a moment. So here's my formula that I just showed you and how we put that formula all together. And you notice the only variables you're going to need are the radius and your height. Both of them are given to us in the figure. So we're just going to do the plug and chug business. So you can see I plugged 3 in for the radius, 6 in for the height, and 3 in for the radius here. Now I went through and I said 2 times 3 times 6 is going to give me 36. 3 squared is 9 times 2 is going to give me 18. And notice how I just brought pi down. I didn't multiply it in yet. So when I say 36 plus 18, I'm going to get 54. And notice I have 54 pi inches squared. This is the exact surface area in terms of pi. And the reason we say exact is because pi decimal never ends, it goes on forever. So if I want my equal sign to be an equal sign, I have to leave my pi in there. But if I want to multiply 54 by pi, it becomes an approximate area of the cylinder. Okay, so this is exact, leaving it in terms of pi, and leaving it in terms means leave pi in it. And then approximate is 169.65, and that is because I multiplied 54 by pi. And notice how, even though it told me to find the exact, I put them both up here, just so that way you would know how to work them both out. Okay, for the cylinder below, find the exact total area and volume. We're not worried about the volume right now. Find the approximates using pi or 3.14. I always use pi. I never use 3.14. So there's my formula. Notice that my radius and my height are given. This is where I start the plug and chug. I plugged in 4 for the radius, plugged in 28 for the height. Notice how I multiplied through everything, but I left pi. So 4 squared is 16, times 2 is 32. 2 times 4 times 28 gives me 224. When I say 224 plus 32, I get 256 pi inches squared. Remember, this is exact, where I'm leaving it in terms of pi. And then here is my approximate. Whenever I say 256 multiplied by pi, I'm going to get approximately 804.25. And I put those answers up here in this blank. And here's an oblique. I just wanted you to see that we don't do an oblique any differently, okay? You've always got this extra line that's drawn in that will tell you what the height is, okay? This, where this altitude is slanted, or the axis, that will always be longer than the actual height. So here's our formula. We're going to plug and chug. My radius is not 4.5. My height is not 15. I've got the wrong problem here. Let me see what happens. No, it still keeps going through with the wrong problem. Okay, well then let me put in the right problem. I remember doing this problem because I thought 42 was such a huge number. This is going to make the video be a little longer, but oh goodness, I did the wrong one. But let me go through here. Let me change this to white. I'm going to cover that up. I'm going to cover this up. And I'm going to cover this up. Okay, so I'm going to go back and I'm going to say, alright, if you'll notice, they say that 42 is equal to the radius up here, but it's not really the radius, it's the diameter. So let me change that too. This is crazy because I remember working this problem. I do not know how this happened. I will have to go back and figure it out and correct it so it doesn't happen again. Alright, so for this up here, I'm going to make this, I'll just do 24. This is equaling D, the diameter. Okay? So remember, if they give you the diameter, you're going to have to divide it by 2 to get the radius. So if my diameter is 42 miles, that means my radius, let me do this in red so it'll stay. Our radius is going to be 21, and that was the number that I thought was rather large. But it's alright. We can still do the math. That's 18, and then here's my radius. And then I'm going to come down here to my next row. Come on. I'm going to say, why does it keep, well, it says it's 36. There we go. I don't know why all of a sudden we had to put my picture up there. And I'm going to say 2, and I'm going to have to type in 3.14 here because I don't have a pi symbol. You know what, let me do it this way. I'm going to say 2 times 21 times 18. It's given, I remember working this, 756, and then I'm going to put in parentheses 3.14. And then I'm going to put my plus sign, and then 21 squared. Remember, you do your exponents before you multiply. Times 2, it's going to be 882. And I'm going to put 3.14, just like that. Then I'm going to come down here and I'm going to say 756 multiplied by pi is going to give me 2375. I'm just going to put 0.0 because it won't round. And then 882 times pi is going to be 2770.88. I'm just going to put 9. Let me go back and do something right quick. I left out a step. If I'm going to do the exact, I'm leaving it in terms of pi. Don't forget that. So if I'm going to do the exact, I'm going to have 756 plus 882 give me 1638, and I know I have a pi symbol in here. There we go. Math operators, common symbols. Well, maybe there's not a pi in here. I could have swore there was. Nope. None of them. Okay, so when I'm leaving it in terms of pi, what I'm just going to do is come down here and I'm going to write out pi. And that is miles squared. And then on this next one, I'm doing the approximation. So I'm going to say S equals, and I'm going to say 2375 plus 270.9. It's going to give me 5145.9 miles squared. There we go. That's how you really work that problem, and I remember all those numbers from working this problem before. I don't know why. I must have accidentally copied over something, so I apologize for that. Anyway, there's the answer to that problem. Oh, and remember, let me go ahead and see if I can plug in this picture. I know I saw this up here before, maybe I didn't. It's my imagination. Oh, there it is. This right here should be right there like that. I can make it a little smaller. Maybe, maybe not. There we go. It should also be on this other one. It should be right there as well. So, because those are approximations. Okay, on to the next slide. Well, not those. Ignore those. Ignore those. Here's the summary of this lesson. They're summarizing here what the definition of a cylinder is. They're talking to you about the altitude, and they're talking about what the axis is, and then they're talking to you about the formula. Now, I use this formula right here as we were going through. It's the same thing as this. It's just this is more detailed. This is an abbreviated formula. This one's more detailed, and it's the one you're actually going to be using whenever you calculate the surface area. So let me see, one more slide. This right here is you should be reading through the 2.08 lesson in your LMS and the reference guide. These are the problems that you should work in your problem set to get good practice for the quiz 2.08. After you work these problems, if you have any questions, just please let me know and I'll be glad to help you. And make note of any general questions you may have when you attend CC on Thursday. And thank you very much for